Gentlemen, my name is Dmitry Ovchinnikov, and I have to send my apologies for Mr. Fergal Moynihan. He couldn't make it today due to family commitments. I'm with EMC for just under 6 years, and I'm working for a global advanced manufacturing organization, which is responsible for running projects with strategical initiatives for manufacturing. And the topic is going to be a digital transformation in EMC for manufacturing. So as such, the whole presentation is going to be divided in 3 parts. At the start, I'm going to talk about the EMC as a company, and then followed by the introduction of the actual changes, and what I'll finish up by the technology that we employed during this journey. EMC Corporation was founded by Richard Egan and Roger Marina in 1979, and ever since it was a leader in information technology from perspective of data storage, management, and protection. And since information is developing in the exponential progression, and by year 2020 it's going to reach a staggering number of 44 zettabytes, which is absolutely incredible. And if you think about it in physical terms, it's essentially as many stars in the universe as we would have bits of data. So EMC continues to be relevant in the companies on their digital transformation with the development of Internet of Things and social networking. So I'm going to speak about the digital universe. So you can see that as a physical universe, the digital universe is huge. As I just mentioned, it contains enormous amount of data, and it will continue to grow over time. So if we take an iPad, and the memory in this iPad would represent the amount of data in 2020, and it would be a stack of 6.6 stacks reaching from Earth to the Moon. So that's the physical representation of the data in year 2020. But unlike the physical universe, the digital universe is software defined, and it's the software that is really taking out the value out of all this data, and this presents opportunities for businesses to get the value of this data, and it really helps companies to drive their business forward. So they can flatten their organizational structures, they can see what the customers want, and really prepare themselves for third platform unites social networking, mobility, and stuff like this. So EMC was under the same transformation journey from perspective of manufacturing as well. And in the past, there was a single model product with a direct sales model profile, small manufacturing base, focused on just keeping up with the growth. But this has changed dramatically with the number of acquisitions and the product base growing to over 24 products, which is quite amazing. So overall, the cost-saving ideas came into play eventually. So the landscape of manufacturing had to change as well. So we had the idea where different enterprises, or how we call them, different business units, they continue on their digital transformation journey separately, and at some point they all got rolled up together and integrated, and which gave us an opportunity to communicate between marketing, operations, finances, manufacturing, and it was essentially the same data everywhere. So operations could make quick decisions on where they produce products based on material hubs information. Finances could get their data very quickly as well. And at the same time, we received this vision from our top management, any product, anywhere, anytime, which had to be translated into objectives. So essentially what it meant for us, we had to produce any product in any location worldwide within a 3 months period. So essentially you had to be able to set up a greenfield site within 3 months. So we understood that we really need to have an application platform that would connect all these entities together, and we came up with this concept of application integration cloud. At the time we were using Oracle as our ERP system, and we're changing over to an SAP environment. And the application was rolled out as well to connect all the legacy applications and any future applications within factory itself, internal manufacturing, as well as external manufacturing and suppliers. This hasn't been done before ever, so all of our old processes had to be scrapped, and we had to come up with the new processes that would enable us to work this strategy. So the global fulfillment footprint is quite large. So we've got 3 captive plants, one in Owens in Ireland, and 2 over in North America, one in Apex, North Carolina, and another one is in Franklin, Massachusetts. And we have quite a significant footprint as regards of our contract manufacturing. We've got 2 plants over in China. We've got few in Europe, one in Brazil, and a number of them in North America as well. And quite a significant coverage from supplier base as well. Now I'm going to talk about the tools that we had to employ along the journey. So to translate information from our customers to the contract manufacturers, we had to employ EDI. The POs were coming out to the suppliers in the form of 850 signals, which they had acknowledged on the 855 signal. And when the shipment was done, they used to send us an 856 signal. At the same point, we had to come up with a concept how we are going to translate genealogy, where before we used to implement almost a factory in the factory concept. All the tools, testers, SAP terminals and whatnot was sent over to the factories around the globe. And then they would use it and send us all the data. We couldn't use this concept anymore as such, since we are going more into virtualized environment. So we came up with the concept of data exchange, where suppliers used to send us data on genealogy, the family trees, the quality data, and debug data as well. The keystone of this transformation was manufacturing test automation cloud. So essentially it's a platform environment and then a content for each individual product family. PRS or data domain, USD, Isilon, USD, and the Extreme IO would be examples. We also used a number of other manufacturing services, such as Unified Manufacturing Configurator. As you can appreciate, with a number of different product families, we have different rules for assembly of the I/O cards, the slicks, racking rules, cabling rules, whatnot. So we came up with a concept of Unified Manufacturing Configurator that enables different products to be assembled as per purchase order. Where if there is a shortage of parts, our contract manufacturers are able to do automatic search of the substitutes and change their flat bombs. Allows us to send change requests and quality notification to our suppliers and contract manufacturers. And currently we are working on the concepts of robotic process automation, or so-called software robots. So it is as such an artificial intelligence whereby copy and paste operations are replaced by a software robot. And I just came off of the presentation of Dennis Kanti, who was working on the Internet of Things with Tycho. So I thought it was a really great presentation where he really explained what this is really well. So if I could invite Dennis to the stage and give us a little bit more on this. Sorry for putting me on the spot.
Thanks, Dmitry. Yeah, this is obviously the second time now that I've actually been brought up. I was brought up earlier than my actual allocated slot, so I'd like to really thank Dmitry. We used to work together in EMC, and I actually worked on that Cumulus platform before I actually moved to Tycho. But this concept that Dmitry is talking about in relation to software robots is something that's happening within the actual devices of IoT as well. We're trying to replace manual tasks that existed over the last number of years with automation. And the only way you can actually do that is by building algorithms that are based on machine learning topologies like regression, clustering, classification, deep learning, these types of things. And what people see this sometimes as a threat in relation to technology versus mankind, that they're consuming our jobs. The reality is that they're not. They're just creating new jobs that spore out of this, and then we can actually, the humans can focus on the more kind of attractive positions, and maybe some of the manual copy and paste that Dmitry mentioned in relation to the software robots can be handled by the machines themselves. So is that okay? That's great. Thanks.
Thank you, Dennis, and that's precisely how it is. That would be really everything for me. Hopefully it was informative for you guys, and thank you.